Assalamualaikum warahmatullahi wabarakatuh. We are from group 4 and here we are about to present our project assignment. Our topic is transportation problem and our group have 5 persons, that is Muhammad Iqbal Hakim bin Nazarimi, Muhammad Fi Azri bin Abdullah, Muhammad Akif bin Rosli, Muhammad Amirul Azlam bin Mazlan, Muhammad Amir bin Rosli. Firstly, we start with introduction. Transportation problem is a particular class of linear programming, which is associated with day-to-day activities in our real life and mainly deal with logistics. It aids in distribution of resources and their movement from one location to another. To meet the specified needs, the goods are carried from a set of source, such as a factory, to a set of destination, such as a warehouse. To put it another way, transportation problems include the transport of a single product manufactured in several different plants to a few different warehouses. This slide for our question 1. 5 warehouses are supplied by 4 factories. The supply available from each factory, the demand at each warehouse, and the cost per unit of transporting goods from the factories to the warehouses are summarized in the following table. Use the northwest corner method to find an initial basic feasible solution of this problem. Find the optimal solution of the problem, i.e., the solution that minimizes the transportation cost, clearly showing and explaining your working. Here are our solution for the northwest corner method. The allotment are made from the top left corner, because according to the northwest corner method, F1 and W1 has to be the starting point. First cell is F1 and W1, and the number of units can be allocated are 12 from the demand side. After that, the remaining F1 supply 28, W1 demand 0. So after that, the entire column of W1 will be deleted. Here the table after W1 has been deleted. Next, we focus on F1 and W2 cell. 15 units will be allotted from the demand side. Then, after that, we focus on F1 and W2 cell. 15 units was allotted, which we take from the demand side. And after that, the remaining unit F1 supply will be 13 and the W2 the demand will be 0. So we can delete the entire column of W2 because the demand is 0. Next is F1 and W3 cell. 13 unit will be allotted, which we take the 13 for the supply side. And after that, the remaining unit for the supply will be 0. And the W3, the demand will be 7. So the entire row can be deleted. Net allotment will be in F2 and W3 with the 7 unit which we take from the demand side. After that, the remaining unit for the F2 supply will be 3 and the W3 demand will be 0. So the entire column of W3 can be deleted. For the net allotment will be focused on F2 and W4 with the 3 unit which we take from the supply side. And after that, the remaining unit, the F2 supply will be 0 and the W4 demand will be 15. And the supply side for the F2 must be 0, so we can delete the entire row of this. After that, we focus on allotment for F3 and W4 with the 12 unit which we take from the demand side. And after that, the remaining unit for the F3 supply will be 8 and the W4 demand will be 0. So we can delete the entire column of W4. For the net allotment will be made in F3 with W5 with the 8 unit which we take from the supply side, and after that the remaining unit, the F3, the supply will be 0, and for W5 the demand will be 18. So the F3, the supply was 0, so we can delete the entire row of F3. Lastly, net allotment will be made in F4 and W5 with 10 unit, and after that the remaining unit for the F4 will be, the supply will be 10, and for W5 the demand will be 10. And at last, nothing will be remain for any row or column. Now just multiply the allocated value with the respective size value and the cost, and add all of them to get the basic solution. So here the initial basic feasible solution, we start from the F1, 13 multiplied with 12 plus 9 multiplied with 15 plus 15 multiplied with 13 plus 12 multiplied with 7 plus 12 multiplied with 3 plus 12 multiplied with 12 plus 9 multiplied with 8 plus 10 multiplied with 10. And after that, we get the answer 922. That's all from me.
Okay. Question 2. Find the critical path from each activity network and find ES, EF, LS, and LF. Okay. First thing first, all we need to do is we redraw it with our typical notes. So right here, we just draw the diagram before I explain in detail. Okay, so this board we refer activity with duration, and then we have early start, early finish, late start, and late finish. Okay, now starting at activity A, we start at 0 for early start in a column as the beginning of the day. So A, its duration is 2, so we have 0 plus 2 equal to 2. So this is how we get early finish. Then what we do is we bring the 2 down at B. Again, 2 plus 4 equal to 6. So C, E, F same as B. How to get the early finish? For D and I, it depends on C. So the early finish 16, we're gonna bring that to D and I. Okay, for G, again, same. We bring to the 22 at ESG. 22 plus 7 is 29. Okay, for the H, there's two different arrows coming, which G and E. In that case, we have to pick the larger of early finish. So obviously at G is the larger than E. So we gonna bring down to early finish at H 29. So again 29 plus 9 equal to 38. Okay, for N, the 38 we put at N. So same, 38 plus 2 at equal to 40. Okay, at J, we found the same case as H. Same, we need to choose the larger one, which is F is the larger one of the EF 25. So we bring over to here. So yeah, same, 22 plus 8 equal to 33. At the value of K and L, we the value of 33, we put them into the K and L for a early start. So for n same too, we need to choose the larger one of EF between K and L. So obviously we got L is the larger one. So we put 38, put here 38 plus 6 is 44. So this is how we get the value of ES and EF each activity. So now how we get the value of LS and LF. In that case, we're gonna have to do the backward pass. Firstly, we're going to bring the 44 down to LF, which is the value of LF at N44. First, how to get the value LS? We need to subtract late finish with duration. So yeah, 44 minus 6 equal to 38. So that's it. We get the value of LS and LF. However, in that case, we found the different arrows count, which for example G. We found the different arrow between the K and L into G. So for this case, we need to choose the some smaller value of LS. So as we can see, the smaller values is L. So we put the 33. Put here 33. So 33 minus 8 equal to 25. So this is how we get LS and LF. So the next slide is the critical path for activity network. So there are six paths for activity networks. So the path 1 is 40, the value is 40, and path 2 is 31, path 3 43, and path 4 44, path 5 is 41, path 6 is 42. So the critical path is path 4 because they have a long time which is 44. So the critical path is path 4, which is A to B to C to E to F to J to L and to N. So that's all the answer of explanation in question 2.
Assalamualaikum. Today I will present about question 3. Okay, this is the question 3. The question is a manufacturer made two types of toy A and toy B. 3 machines are needed for this purpose, and the time is in minutes required for each toy on the machine is below. Okay, for the type of toy, have a type A and type B. For the machine, I have 3, 1, 2, 3. Okay, if machine is available for a maximum of 6 hours per day, if the profit and on each toy of type A is 7 ringgit 50 cent, and on each toy of type B is RM 5 ringgit. Show that 15 toys of type A and type 30 of type B should be manufactured in a day to get a maximum profit. Okay, for the first step, kita akan tukarkan yang A tu jadi X1 dan yang B tu akan jadi X2. Okay, ini merupakan constraint yang kita dapat. Yang pertama, step yang pertama kita akan dapat maksimum Z sama dengan Z sama dengan RM7 X1 tambah 5 X2. Okey. Ini yang step kedua, tu X1 tambah X2 lebih kecil daripada 60. Okey, yang untuk yang kedua, untuk yang ketiga, step ketiga, X1 lebih kecil daripada 20. Untuk step yang keempat, 2X1 tambah 3X2 lebih kecil daripada 120. Dan step kelima, X1 sama dengan X2 lebih besar daripada kosong. Okey. Okey, yang pertama yang macam mana kita dapat sequence yang tadi? Yang pertama, kita ambil daripada jadual yang diberi dalam soalan. Okey. Untuk yang mesin pertama, 2X1 tambah 6X2 lebih kecil daripada 360. Oleh kerana nilainya terlalu besar, kita akan kecilkan dia. Di mana 12X1 tu akan dibahagikan dengan 6 dan 6X2 tu akan dibahagikan dengan 6 juga. Dan 360 tu merupakan hours yang minutes yang dapat daripada mesin itu. Okey. Okey, jawapannya akan dapat 2X1 tambah X2 lebih kecil daripada 60. Yang kedua, 18X1 tambah 0X2 lebih kecil daripada 360. Okey, 18 ni X1 ni akan dibahagikan dengan 8. Yang X2 tu kosong, maknanya tadi nilai. Okey, lebih kecil daripada 360 ini akan dibahagikan dengan 18. Oleh itu kita akan dapat X1 lebih kecil daripada 20. Yang ketiga, 6X1 tambah 9X2 lebih kecil daripada 360. Okey, yang ini 6X1 ni akan dibahagikan dengan 3 dan 9X2 ni akan dibagi dengan 3 juga dan 360 ini akan dibagi dengan 3 juga. Oleh itu jawapannya akan dapat 2X1 tambah 3X2 lebih kecil daripada 120. Okey, yang keempat, X1 dan X2 lebih besar pada 20. Oleh kerana jumlah-jumlah di atas kita dapat nilainya positif, graf yang akan kita lakarkan merupakan graf akan ke kanan. Okey. Seterusnya saya akan Akif akan membentangkan.
Okay, Assalamualaikum. So kat sini this slide is about constant calculation for graph plotting. So as you see just now from previous presenter, which he explained about how we can get the 60 and what we call the numbers behind this. And now I want to explain about how we can get the calculation for graph plotting. Okay, firstly, for the first constraint, 2x1 plus x2 equal to 60. Okay, the first one, we need to make a box, which is x1 and x2. And the first step is, as you can see my cursor, x1, first we put 0, then we start from x1. So when x1 equal to 0 and x2 equal, so in this section there is no x1. So x1 will be like we call 2 times 0 plus x2 equal to 60 and x2 equal to 60. Then we put the 60 inside the x2 column. Okay, and then after that we put 0 at the next x2 column, and we want to find the x1. So how we can get the t? So b, when x2 equal to 0, x1 equal to 2x1 plus x2 equal to 60. So there is no x2, 2x1 equal to 60, and 60 divided by 2 equal to 30. So that is how we can get 30 for constraint number 1. So now we move to constraint number 2, which is x1 plus 20, x2 equal to, then we repeat the same step again, which is x1 and x2, we make a box. Then the first one, x1 we put 0, and for x2, we do when x1 equal to 0 and x2 equal to, so it will be like x1 plus 20x2 equal to 20. So the answer will be 20 for the x2, and then we repeat the same step again, which is we put 0 at the x2 column, x2 second column, and we want to find the x1. So how we can get the x1? When x2 equal to 0, x1 equal to, so it will be like x1 plus 20 equal to 0, because there is no x2 equal to 0. So the answer, this is how we can get the second constraint. Okay, for the third constraint, 2x1 plus 3x2 equal to 120. So we want to find the plotting. The first, we repeat the same step again, which is x2 and x1 and x2. The first step is we put 0 at the x1 column, then we move to x2, which is we can get 40. How we can get 40? So as you can see, 3a, when x1 equal to 0, x2 equal to, so 2 times 0 plus 3x2, because there is no x1, it will be 120 divided by 3 equal to 40. So this is how we can get the x2. And the next step is we put 0 at the x2 second column, and we want to find the x1 second column, which is the last point for the graph plotting. And as you can see, b, when x2 equal to 0, x1 equal to 2x1 plus 3 times 0 equal to 120. Because why 3 times 0? Because we want to find the x1, not the x2. So the x1 equal to 120 divided by 2 equal to 60. And this how we can get the graph plotting from constraint number 1, constraint number 2, and constraint number 3. And for the next, I will pass to the next presenter, which is Amir.
Assalamualaikum warahmatullahi wabarakatuh. So for the last, we have to kita perlu lakar graph. So for the first is corner point Z. Corner point Z is 7.5 x1 plus 5 x2. So for the A, 20 0 equivalent to 150. 20 equal to 20 equal to 20 equal to 150. 15 which 13 is equivalent to 262.5. 0 to 40 equal to 200. So the maximum value of Z is at 262.5, which at 1530. So for our plotting in the graph, so we have a tree to constrain the graph. So for the first, we have to plot on the graph the three piece of constraint. So for the first 0 plot on the graph. So let A is equivalent to 0. So B 0 equal to 60. So B 0 equal to 30. So for the plot, we plot this in this case 30 and 16. So this is for plot A. So for the plot B, we have dia termasuk dalam dia A besar A ada 30. So A ada 30, so B adalah 60. Jadinya titik sini 60 besar 30 adalah bersilang bersamaan dengan, so untuk titik B pula dia 15 30. So dekat sini 20 sini 60 201 tambah X 2 lebih kecil daripada 120. Jadinya dia bertitik 60 hingga 40. So di sini adalah titik bersilang dia. Jadinya untuk seterusnya, untuk 20 adalah bersama 20 ke atas adalah bersama kecil daripada 20. Sebab titik B adalah 20 dan dia adalah ke atas. Jadinya dia kecil daripada 20, jadinya dia memang menuju ke atas for the each point. So this is for manually. So for the automatically, we use the Desmos calculator. So A equivalent to X, so B and equivalent to Y. So including the graph is jangan tersalah tukar, kerana bila tertukar dia akan jadi jawapan dia lain. So untuk setiap bawah line kita akan mencari titik persilangan. Jadinya titik persilangan 2x tambah x2 lebih kecil daripada 60, jadi bersilang di sini. Jadinya 15 30 adalah sini, 20 20 sini, dan di 30 20 sini, jadinya 60 40 kat sini. Dia bersilang. Jadinya bila kita dia nak lebih kurang daripada maximum value z is to 62. So kita punya kawasan lorekannya adalah di bawah sini. Jika kita tersalah lorek, jawapan dia akan lari. So for the equation is proven sangat proven kerana cara ini adalah proven untuk mencari kawasan lorek di bawah sini. Okay, that's all from me. Thank you.